So today I'm going to talk about the issue of microplastics in the environment. So raise hands, how many people are concerned about microplastics in the environment? Pretty much everybody who's willing to raise their hands. Who feels they have a good grasp on what the effects of microplastics in the environment are? Raise your hands. I got nothing. Yeah, to me that's kind of where the rubber meets the road. You know, I've been a monitoring person all my life. Mostly working on things like flame retardants and oil and the like, and measuring their distribution. But really, one of the big questions is, and the communicator earlier said, I think the key word, why. And with microplastics, one of the questions is why. You know, are they a problem? Are they not a problem? I'm not going to answer that question totally here today, but just to give you, I guess, a taste of what I think is important regarding to that. So we did a study, it was funded by NOAA, basically to look at the interaction of an infectious disease with a very important fish species and different types of microplastics. So it's kind of a multi-component issue here. So it was myself, my former graduate student, Meredith Seeley, who's now in NIST in Hawaii, Andrew Wargo, who's our fish specialist, Wolfgang Vogelbein, who's a pathobiologist, and Dr. Zwala, who's an immunologist at William & Mary, so it was a team effort here. So in the real world, again, all exposures are multiple. There are multiple stressors. You know, when we do lab experiments, a lot of times we'll take fish in a tank, and we'll put one chemical in there, and we'll determine an LC50, but that's not the real world. So we were trying to get a little bit more realistic with that. And so the species of choice for us was the rainbow trout here, partially because Andrew Wargo was a specialist in handling those in our laboratory. Also, there were representative salmonidae, which are extraordinarily important fish in terms of their position in the ecosystem as well as in aquaculture. The disease we chose to work with is also very important in terms of impacts on salmonids, something called infectious hemopoietic necrosis virus, or IHNV. It really whacks out the fisheries, particularly in the Pacific Northwest, and actually can cause up to 90% mortality in some populations in aquaculture. We were really interested in looking at different types of plastics. One thing I did learn over the years I've been working on microplastics is plastics are not all alike. We kind of group them together, but they are quite a bit different in terms of their composition. I like to tell my students the class I hated most as an undergraduate was basic organic chemistry, and I became an organic chemist, sort of. And the discipline within that I hated the most was polymer chemistry. And so, you know, God punishes those. But anyway, we looked at different types of plastics here, including nylon, which is used a lot in nets. You see it washed up on beaches, is used in aquaculture. Polystyrene is used a lot in floats. And you see large amounts of debris piled up on shorelines, particularly in the Pacific Northwest and Alaska. A lot of the tsunami debris was polystyrene. And then we had this kind of wacky idea is, well, if we do see any effect, is it because it's just a particle or is it because it's plastic? So we actually included little bits of Spartina, which is a very abundant Chesapeake Bay marsh grass there, just to kind of cover that issue. And we ground everybody up. Believe it or not, it's actually not that easy to make microplastics. The environment seems to do a really good job, but in the laboratory it's difficult. We actually had to, in many cases, apply liquid nitrogen and then put it into a kind of a complex ball grinder to get it ground up. Spartina is pretty easy. We just able to throw that to a blender. And we produced microplastics on the order of 20 micron here. And we also worked as a kind of unusual thing with fibers. When we first started this, fibers weren't really on our radar. Now a lot of folks know from monitoring, and particularly wastewater treatment plants, that fibers are actually one of the most abundant types of plastic. So we work with fairly large fibers here in terms of our exposure scenario. And this is just kind of a snapshot of what the fish operation looked like. We basically had a series of tanks, some of which had nylon exposure, some had polystyrene, some had Spartina, and some had no particles. And then half our exposure scenarios had no virus, and half had virus in it. And then we tested different concentrations of each of these microplastics in here to see if there's a dose response here. And we did everything in triplicate, and thank God I was an environmental chemist and not basically the animal husbandry person for this operation, because taking care of all these fish was a big issue. This is just a picture of the setup in Andrew's laboratory. We had well over 1,000 fish going at one time, so the graduate students were kept busy taking care of this operation. Some nitty-gritty details of how we did this thing. We basically did a 56-day study. At day 28, we actually introduced the virus. So prior to that, there was no virus. So this is kind of a, whether you want to call it chronic or not chronic exposure, but basically 4 weeks of exposure to the plastics. We renewed the plastics every day and did water quality monitoring. So that's kind of the generic overview of the exposure scenario. And it's going to be really hard to see, I know. Sorry about that. And this pointer's not going to help you much. I'll go through it fairly simply here, but this just shows you some of the exposures that we ran. So we had nylon fiber here, and we had polystyrene in the middle, for those who can't see my pointer, and Spartina here, and days along the x-axis here, up to 56 days. And then the y-axis is basically survival of the fish. So basically, if it goes all the way to the bottom here, nobody survived. If it's a straight line at the top, everybody survived. And one of the interesting things we did see is that when the virus wasn't present, even when we ran it out 56 days, we exposed them to nylon, polystyrene, Spartina, no matter what the dosage was, almost nobody died, which a lot of people were overlooking at. But to me, that was a really important point, is that, hey, we did a study with probably environmentally unrealistically high levels of microplastics, and alone, nobody died, which I guess is a good thing. We're sometimes, upset about it in our toxicology experiments. But when we introduced the disease, we had about 20% mortality in the absence of the particles. So that's shown right here, this little black line here. But when we actually introduced the disease and the microplastics together, we got some really interesting results. No matter what type of particle it was, when the virus was present, the particles enhanced the mortality in the fish. And the ones that enhanced it the most, up to about 80% mortality, were actually the nylon fibers. So it took both of these things together to really kick off a lot of mortality above and beyond what the virus could do by itself. We thought that was pretty interesting. This is where some of the histopath work was done. We wanted to know why, what's going on, what's causing this. And our theory was that probably it was some sort of physical damage. So this is just some histopath work here showing the gills of the fish. And what we think is happening is that the microplastics, particularly those fibers, were irritating the filaments in the gill, and that was perhaps enhancing the penetration of the virus into the fish and causing higher mortality. This is just some data looking at the extent of the disease, and basically what you see is exposure at day 28 basically to the virus, and there was a big spike in regards to the degradation of the gill tissue initially in nylon. You also saw some in polystyrene. Interestingly enough, we didn't see much in the Spartina there at all, which actually didn't really even line up that well with the control. But when you're looking at fish, they just don't like to cooperate. But this is kind of our idea here, that fibers physically disrupt the gill membrane more so than other types of microplastics. So we published this paper earlier this year in Science of the Total Environment. If people are interested, I'll get you a copy of it. And basically, this is just kind of the summary of what we found here on the left here, is that in the absence of disease, very little mortality. With just microplastics alone, really baseline mortality. But when you added the two together, particularly in regards to the presence of nylon, you really had this big spike over here in regards to the deaths of the fish. One of the other questions that came up is, well, how can we get a better handle on what's going on? We basically were exposing all our fish to microplastics throughout the study. So what if we didn't expose the fish in the first half of the study and then give them the virus and then give them exposure in the second half? That would basically indicate, well, perhaps it's not the damage being done by the plastics. The other question was, well, compositionally, is the nylon so problematic because it's nylon or because it's the fiber? So that was another big question. So this is the same sort of setup you saw here before, 58-day exposure. Either we exposed the fish throughout the whole thing to the nylon, or we only exposed them to the first half or during the second half here. And this just shows you kind of the same thing in regards to the fish tanks themselves. So half of them got virus, half of them didn't get virus. Also gave us another chance to check that nylon fiber impact just to make sure it wasn't some sort of fluke, so we repeated the experiment. We've actually done it several times since, and it's pretty consistent that the fibers are problematic. Again, a hard to see graph. But basically what we saw is, again, exposure to microplastics alone had modest mortality, a little worse than what we had in our other experiments. Exposure to the nylon powder itself really didn't have much of an impact relative to those controls. Exposure to the nylon fiber had a significant impact, whether it was chronic throughout the entire 56 days or it was just basically during the first 28 days. So that's just indicating that physical damage is probably being done to those gills. And then we introduced the virus, in the way it goes. So we think that was pretty interesting. So we're moving on now. Again, trying to be more environmentally realistic. So we've started to take plastics and expose them to UV radiation. So, all the plastics that people usually use in their laboratory experiments are taken off the shelf. They're not weathered. They're not really realistic. So we got basically a UV weathering chamber shown here, and zapped the crap out of some of our plastics for different lengths of time to basically artificial weather them. And now we're doing some experiments, basically looking at what the effects in the same sort of system those UV weathered plastics have. So I think that's it. And the choice of a symbol here as similar to the Deathly Hallows out of Harry Potter is just circumstance. So I think if I got time, I'll try to answer any questions. Thank you.
We definitely have time for questions.
What's your anticipated results for the weathered? This is working on the weathered plastics versus the fresh plastics.
Putting it close enough.
Yeah. In terms of the nylon fibers, we're probably expecting not that much of a difference because they're still intact. If it were a chemical effect, we might very well see a decrease in impacts. What happens, a lot of plastics are pretty aliphatic in nature. They're highly reduced, which is kind of alien to a lot of biota. They're used to assimilating, chewing up things that have oxygen and nitrogen and things along that line. So that's more consistent with them in regards to their assimilation of it. Also will change the physical properties a bit. If it does make them a little more brittle, that could actually increase toxicity, but could cause greater damage. Another area that we're really interested in, which can be affected by UV exposure, are the chemical additives. So I'm actually more of a chemical additives person than I am anything else. And we are examining some of the materials for any alteration in those. And we've actually seen, one of my colleagues at VIMS, BK Song, he's a microbiologist, And he was looking at the effects of microplastics in a kind of simulated wastewater treatment scenario where they're looking at nitrite production, which is a big issue in treatment plants, the fate of nitrogen. And he actually was saying that some of the plastics were enhancing and other ones were inhibiting nitrite production in there. And PVC was one of the more problematic ones, which is present PVC pipe everywhere. But he did find that the effect was reduced somewhat after UV exposure, and we went in chemically and looked at the composition of the additives, and we actually saw one of them disappear and a new one appear from the UV exposure. So it's a factorial scenario. Again, going back to the idea that all plastics are not alike, that there's so many differences in there that you have to treat them almost individually, which is almost impossible to do because there's, thousands of different products out there. But that's the nature of the beast. And that's, like I say, one of the take-home messages is people talk about plastics. There's just a huge range in terms of their behavior, their usage, their presence in the environment, and probably their toxicological impacts.
I was actually going to ask if you have any plans to look at sort of consortia of plastics, so admixing them to see if the effect is worse than, say, the fibers solo. Yeah,
mixtures are always, the 500-pound gorilla in the room. We will probably start working with some what I will call natural assemblages of plastics that we've pulled out of the environment, which will be a mixture. But part of the problem is that the possibilities are endless. My strategy has been more to find, if I can, the worst case one, which these individual tests help you out. Like I say, before we got fiddling around with it, fibers were kind of just a curiosity, and now we're finding that they may be extraordinarily important. So that allows us to, put that in a box and say, well, that could be problematic. Some of these plastics that have some additives, my personal favorites I've always worked on were flame retardants, and some of those are very environmentally problematic. If we find those are toxic, well, maybe the chemical engineers can focus their attention on, on that aspect of it. So it's more of a point-by-point thing. But yeah, I very much respect the concept of mixtures being, what we all are exposed to, along with other stressors.
Have you looked at oyster shell bags used in living shorelines, or is that like the nylon fibers?
Yeah, I mean, a lot of those are nylon fibers. Shellfish have been a big point of interest in regards to exposure bioaccumulation of microplastics. I personally haven't gone after them. One of the interesting things that just came up in the last couple of weeks, VIMS has a big oyster hatchery. They just built it a while ago. I think it just opened last year. And they've been having die-offs in there, and so they were asking me, well, could it be the plastics in there? And, I go in there, and the inside of the oyster hatchery is probably twice the size of this room, and all along the roof, and all the water is coming through PVC pipes. And I don't know that it's that or it's just a water pickup. But I'm keenly concerned about potential impacts of microplastics in general on shellfish, but also some of the additives. For example, tributyl tin was a big issue in the Chesapeake Bay for oysters. We've really stomped that down, basically banned its usage for the most part. They actually use a alkyl tin as a stabilizer in PVC. I saw that and it was like, holy crap. You got all those water lines flushing through there, in this case an oyster hatchery, but in general, does that alkyl tin come out? So we're going to do some experiments trying to do some leaching work to see, if that's coming out, and then do some sort of toxicity assay, I think, with the shellfish to see if there's an impact there. But You know, it may or may not explain what's happening in their hatchery, but just last week I was down there.
Any other questions? All right, thank you, Dr. Hale.
Thank you.